today let us discuss on the topic of defuzzification. So defuzzification is a mapping process from a space of fuzzy control actions defined over an output universe of discourse into a space of crisp, that is non-fuzzy control action. In a simplified way, we can specify that defuzzification is a fuzzy to crisp conversion. So we have some of the defuzzification methods. So we have 4 methods of defuzzification. The first one is the lambda cut method, weighted average method, maxima method, and the centroid method. In the defuzzification method, let us see the maxima method or height method. So in this maxima method or the height method, we'll be having first of maxima, last of maxima, and mean of maxima. Okay. First, let us see what is maxima method or the height method. The maxima method is otherwise known as a height method. The height method is nothing but the peak value. See here we are having the peak value. So what is the peak value? Here we are having 1. So this 1 gives you the maximum value or the height value. Okay. So if you have more than one height in the same position itself, then we'll be having a first of maxima, last of maxima, as well as mean of maxima. So let us consider an example. A fuzzy Young set Young is defined as follows. Young is equal to 15, 0.5. That is the membership value if a person is of 15 years and the membership is 0.5. And if the person is of 20 years means the membership is 0.9, 25, 0.8, 30, 0.5, 35, 0.3. Then the crisp value of Young using height method is, see what here, the maximum height is the maximum value. So here what is the maximum value? We are having the membership value 0.9. So if it is of 0.9 means then what is the value? 20. So the age of that person will be 20. So thus a person of 20 years old is treated as young. The person of 20 years old is treated as young. So this method is known as a maxima method or the height method. Suppose if you have only one single value means then it is known as a maximum height method. Suppose if you have many values in the same height means then we can find the first of maxima, last of maxima, and the mean of maxima. So here we are having an example. See here. That is more than one membership function are having the same height. See here for 2, 4, 6 and 8. Then what we have to do is we have to find the first of maxima. So what is first of maxima? Here the first value we are having is, the first maxima value here we are having is, the value here is 4. Okay. And the next one, the last maximum value here we are having is, see this is the last maximum value. So here what we are having? 0.8. And the next one is the mean of maxima. Mean of maxima means here we are having 3 points. So among 3 points means we have to add these 3 values and we have to divide it by 3. So this will be the middle value. See here, so the first of maxima is here we are having it as 4. So the value is here 4. And the last of maxima, so the last of maxima means here, see here, it is the last value 8. So this gives the maximum value, that is, this is the maximum value, membership function is 0.8 and here it is given as 8. So the last of maxima will be 8. And the next one is the mean of maxima. Mean of maxima means in the same height we are having 4, 6 and 8. So what we have to do? We'll be having 4 plus 6 plus 8. So totally we will be having 3 values. So we have to find the mean value. So divided by 3. So 4 plus 6 plus 8 divided by 3 will be 6. That is 6 plus 4 10. 10 plus 8 18. 18 divided by 3 is 6. So this method is known as the height method or the maxima method.